Okay, now we want to look at hexadecimal system or numeral. You can say what hexadecimal was numeration. So let us put it as well, hexadecimal system. We know that hexa means what? 6. 6. It's just like in your polygon. You have tri to mean what? 3. You have quadri to mean what? 4. We have pent, that is pentagon, pent to mean 5. Hexa to mean 6. 3, 4, 5, 6. So it continues like that. I believe you know. Hepta. We have octa. We have nona. We have deca. And from there, you can continue. If I should ask now 11 now, you'll be looking at me. So this is 9 and this is what? 10. So now, from here, decimal stands for 10, right? Hexa, that is what? That is 6. So this is just combination of 6 and what? And 10. So here we'll be talking about numbers in base 16. So now, how are we going to what? What are the digits in this word, in this system? So what are the digits in this system? So it range from, it range from 0 down to what? Down to 15. But now, if we are talking about 10, 10 is combination of 2 digits. So there is no clarity. That is why there is need for us to use alphabetical letter to denote 10 upward down to 15. So our 10 will be A, 10, 11, 12, 13, 14, 15. 10 will be what? A. Some schools of thought might use capital A, some can use small a, as the case may be. B, C, D, E, then F. Now, that means this will range from 0, 1, 2, comma, 9, comma, A, B, comma, C, comma, D, comma, E, comma, F. Or I can choose to what? To just say A, comma, F. Thank you. Now, so these are the words, the digits that we have in hexadecimal. So now, let us all play around. Let us play around. So, let's say we can convert this value to base 10, right? We are looking at hexadecimal numeral, meaning we are looking at hexadecimal system. So numbers in this system, they are zeros, 1 down to F, meaning it ranges from 0 to 15. But we know that numbers from 10 down to 15, they are represented with our alphabetical letters. So that is A, B down to F. So here now, we are going to look at some questions, and the question we'll be solving is similar to what we've done before, because everything follows the same concept. So for instance, let's say we have this question. We have a question that says, convert this hexadecimal number 1A in base 16 to its decimal equivalent to its decimal equivalent. That is what we want to do. Solution: we have 1a in base 16. We are asked to change it to decimal. Decimal is what? Is base 10, right? So it's still normal way we have been doing it. If you want to use the weight approach, we can go ahead and use that. That will be faster. Or we can use this index, talking about the exponent approach. So let me use the weight. This first digit to the right, we have what? Weight of 1, right? So this next one, we have what weight? 16. 16. So now, let's simplify further. 16 times 1, we have 16 times 1, then we have 1 times a. So we have 16 plus, but our a is 10 in base 10, right? That is 10 times 1, that is 10. So the addition of these two will give us 26 in base 10. So this is how to go about this. Changing from base 16 with the hexadecimal system.
1 times 2 because a is 10.
Because what?
A is 10.
Yes. So now another question. This question says convert. This one says convert 245, which is a decimal number, to its hexadecimal equivalent. This 245, if the base is not indicated, it will be assumed that we have it in base 10. So we are having that in base 10. We have that in base 10. We have that in base 10. So we are asked to what? To get the equivalent form of it in hexadecimal. So let's simplify that together. 245, that is solution, is equal to, that means we will need to use the long division approach. So we'll draw our dagger symbol, or we say cross symbol. So yeah, we have 245. 16 will be placed outside there. Now let's do it together. How many 16 can we see in 24? 1. Remainder what? 8. Remainder 8. Now in 85, that is 5. Because 16 times 5 is 80. So we have a remainder of 5. Am I right or wrong? Right. Now we continue. 16 in 15.
0.
Is 0, remainder what? So that 15 now in base 16, what will it be? That is what? Capital F. You know, some schools of thought might use small f or capital F, but here we are using capital F. So now that means 245 in base 10 is equivalent to F5 in what? In base 16. In base 16. F5. So that is that for that. Now let us look at some addition and subtraction question under this what? Numeration. So another question says add the decimal number. Add the decimal number 3c in base 16 and A7 in base 16. Pardon me for this, since I use a figure here, this one should be written in figure as well. So like this. So to keep uniformity. Now we want to add these two values together. Those two values, we have it in base 16. So we have 3C base 16 plus A7 base 16. Now you remember, anytime we are adding, we must not have a number beyond what the base number. Yeah. The only number that is allowed, they are number from 0 and those that is less than the base number.
The base number and above. We can have the base number and above.
We can.
Okay.
So now we have 3C, we have 7 here, and A will be here. So let's add. Now what is C plus 7? So C is what? C represent what?
12.
It represents, you say 12, right?
Yeah.
C represent 12. So that is 12 plus 7, that is what? 19. So if we have 19, we can have 19 in base 16. So what do we need to do? We divide that what? 19 by what? 16. So what does it give? 1, the remainder 3. So I will write the remainder. Then what am I going to do with that 1? I will carry what? The 1, right? So the 1 is carried. So 1 plus 3, 4 plus A. What is our A? 10. So that is 14.
Yes, sir.
So we can have 14, right?
Yes.
But what does 14? What does it represent? 14 is what? Is E. 14 is what? E. So the addition of 3C in base 16 and what? A7 in base 16 result to what? E3 in what? Base 16. So imagine, you see that, oh, okay, let me leave that. So you can see how the addition is being done. It's still the same way we consider what? The addition process in base 2, base 10, it's still the same thing that is happening here. So let us look at a subtraction question, a question that involves subtraction. So we are asked to subtract this hexadecimal number 2F from 5D. Subtract 2F from 5D, like this. So though you can have more than this, you might be saying that we are playing around 2-digit number. You can extend beyond what 2-digit number. So have that in mind, please. So we have 5D minus 2F, right? So it's equal to, sorry, solution. Okay. So now we have 5D negative 2F, right? So it's equal to 5D minus.
Okay, the base are not important in 16.
No, it is.
You are not putting 16 on that one.
No, I don't believe that we know. We all know that yes, we are working in 16.
Yeah.
You understand? So now we have D minus F. What does D represent? D is what? D is what? For 13, right? And F is what? 15, right? Imagine 13 minus 15 in this scenario is not what possible. You remember I've made that statement before in a kind of setting like this or arrangement like this where we have small number minus big number.
Yes.
So what we just need to do is to borrow from that word the other number beside that, right? So we'll borrow from 5 to this word D. So and the receiver will receive it as well, the base number, right? So that means 16 will be added to what? That D. So that is plus 13, right? 16 plus 13 is what? 29. So what we now have now is 29 negative what? 15. So when we subtract 15 from 29, what does it give? 14. I believe you are together.
Yes, sir.
But what does 14, what does it represent?
E.
It represents what? E. That means D minus F is what? E.
In this case, E.
Yes. Can I continue?
Yes, sir.
So yeah, it's 5 we have initially, but it's now what? 4. 4 minus 2. 2. So our answer is what? 2e, right? So that means 5d base 16 minus 2f base 16 result to 2e in base 16. Please, do we get that? So that is that for that. Now let's see. I want to give you a question to play with, so that you also will be engaged. So let's see how you can what? Correlate what we've discussed in the past with this question. So the question is, multiply the hexadecimal number. Multiply the hexadecimal number 4e and 3. 4e and 3. Okay, now let's look at the solution to this exercise. So you help me with the question. Can someone help me with the question?
4E times 3.
We have 4e in base 16 times what? 3, also in base 16. So it's equal to 4e times 3. We know both number, we have it in base 16. So let's multiply. 3 times e. What is our e? E is what? 14, right? So it means we have 14 times 3. 14 times 3, what will it give? We have 42. We have it to be 42. So now this 42, we can't write it down here because we are working in base 16. So that 42, we will divide it by the base number 16. So how many 16 can we see in 42? That is 2. Remember what? Remember what? Remember 10. Are you sure it's 10?
16 times 2.
It's 32.
Yes, it's 10.
It's not 10. It's 10, it's 10, it's 10. Don't bring bottle. So now, we have remainder of 10, right? And our 10, what does 10 represent? A, right?
Yes.
So here we are going to put down what? A. So now, these 2 here now, we'll transfer it. So what is 3 times 4? 12 plus 2. That is 14, right? So we can have 14 in base 16. But what is the representative of 14 in base 16? It is what? E, right? So that is how we have the answer to become E8. So another question, practice question. Okay, let's do this one together before another practice question. So this question says divide the hexadecimal numbers 72 72 by 3. 72, we have it in base 16, right? 3 is also in base 16. Now, the solution, we are going to have it to be 72 over 3. That is the meaning. Both number in 16, right? So now, okay, let us use this approach. We taking it to base 10, right? Taking each of the number to base 10. So we have the result in base 10. Then we then convert the result back to 16. So let's use the place value approach, that is the weight approach. Here we have 1. Here we have 16. This one will still be 1. So I believe we get that right. So it will be 16 times 7 plus 1 times 2. Everything divided by 3 times, or we say 1 times 3. 1 times 3 or 3 times 1. So this implies what? 16 times 2, we have it to be 112. Am I right? Plus 2 divided by 3. So the addition of 112 and 2 is what? 114, right? Upon 3. So can 3 divide 114?
No.
Can 3 divide 114? Perfectly. I said something yesterday for the rules of divisibility. If a number is given and you want to know maybe the number is divisible by what? By 3. It's divisible. So it's only applicable to 3. Like if the sum of the digits give a multiples of 3, so that means it's divisible by what? By 3. The number here is what? 114, right? The addition of the digit value, 1 plus 1 plus 4 is 6, which is a multiples of. So 3 in 11 is what? 3, right? Now in 24, that is 8. So we have 38, right? So this value, we have it in base 10. We have this value in base 10. Now this base 10 value, we'll now convert it to base 16 by we dividing repeatedly by 16. How many 16 can we say in 38?
2 remainder 6.
2 remainder 6. So how many 16 can we say in 2?
0 remainder 2.
Is 0 remainder 2. So what do we have? We have 2, 6. 26 in base 16. So this is what they asked us to do here. So now, I will solve the first question here. We want to look at conversion from binary to hexadecimal. I'm going to show you the shortcut, and I will show you the normal way. So, and you will take the second one as a practice question.
I have a question.
Okay.
Is there a long division method of solving this?
There is, but it is logical.
Logical.
Yes. So you can see when we are playing around one division question using the normal square root symbol, you can see that in some concept you might be lost somehow. So to avoid that, I will advise you to use the base 10 approach. First convert to base 10, then you convert back to the required base. So we want to look at this question. Says convert the binary number 110101 to hexadecimal. Now solution. If I have 110101 and I want to change it to what? To base 16, right? To base 16. There is a direct way we can use. In base 2, this one is in base 2. We have to change it to what? To base 16. Now, if I have 2, this is 2, right? If I have 16, do you agree that 16 is the same thing as 2 to the power of 4? It's the same thing as 16. And this 2 is the same thing as 2 to the power of 1, right? Now, if we are moving from base 2 to base 16, since it is possible for us to rewrite this was 16 in base 2, So we will just use this power of that 2 to what? To know the what? The number of bits that we are going to what? To consider. Because we are going to what? Have different section of bits. So this 4 will tell us that we are going to have a 4 bits, right? But
this one, right?
Which one? Yes. So now I'm going to what? Group. Like grouping it, let me start from what? From the right hand side towards the left hand side. In group of what? 4, right? So it's going to be what? 1 0 1 0, right? So we have the remaining number 1 1 to fall under a group. So to complement this one to be 4 bits, it will be 0 0, right? Am I right?
Yes, sir.
We are on the same page, right?
Yes.
So what we are going to do at this point now, we have this one in base what? In base 2, this one too in base 2. So each of these base 2 number now, we'll convert it to base 10. So if you want to use the weight approach, this one, the weight is 1 2 4 8. 1 2 4 8, right? So this one we'll just what? Discard what? The one that involves 0. So we have 2 plus 1, right? 2 times 1 2. 1 times 1 1. So we'll add. So and we have what? We have 4 times 1 4, right?
Yes.
1 times 1 1. So we have 3 here. We have what here? 5. So you bring the 2 together. That is 35 in base what? In base 16. In base 16. So let's check. Maybe this is actually what? Correct or wrong?
There was something we were doing. We were converting like the final answer, you added it with 0.
I complement this with 0. No, that one, we are not dividing by long division. So it is when you want to move back from base 16 to base 2. That is where you will need to divide by that long division. And in that case, you will remember, like, each of the results should be what? 4 bits. You get? So this is what we have, right? So let us look at the alternative approach. Alternative approach. If I should have 1 1 0 1 0 1 base 2, right? Now I want to take this one to base 10 first. So using the weight approach, this one will be 1 2 4 8 16. Then here is what? 32, right? So what will it be now? 32 times 1 32. 16 times 1 is what? 16. This one is out. This one, that is 4, right? Plus 4 plus 1. So 32 plus 16, that is 48. Plus 2, that is what? 52 plus 1, 53 in base 10. So this base 10 number now, we are going to convert it to base 16 by we were dividing repeatedly by what? By 16.
Sorry, I need to confirm something. So is it safe to say that you split? Okay, I'm interested in the question for that 1101, right?
Yes.
Is it safe to say that you divided the number based on the power of 2?
No, the power, the power of the 2 for that 16.
So that's the graph splitting the numbers, right?
So, at first, we've seen that, it's possible for us to move directly from base 2 to 16. So, and there must be a criteria in doing so, right? So that 16, we know that we can still have it in base 2, right? And what is the power when we're expressing base 2? That is 4, right? So that 4 will tell us the number of bits that we are going to have So because we are going to have different group, different section of bits. So here we will be dividing repeatedly by what? By 16. How many 16 can we see in 53? That is 48. That is 3. Remainder what? Remainder 5. So we go again. 16 in 3. 0 remainder what? 3. So you can see that we have 35, right? It's the same thing as what we have initially with the shortcut approach. So that is how it works.
The shortcut approach. The first one is shortcut.
So you can see the first one is a thing that is just like we using maybe 2 lines.
Second one feels safe. I want to the second one. It feels safe. It feels like we cannot do this step.
Okay now. Now, I have a question for you guys. And the question is this. You have to convert. This is an exercise. You convert this binary number 100111010 to hexadecimal. So for the exercise question, we all have same result. So we'll be ignoring the solution for now. So we want to look at more questions. So this one is a question on we converting from hexadecimal to binary. What we just looked at previously now is binary to what? Hexadecimal. So if you want to look at how to make conversion from hexadecimal to binary, meaning from hexadecimal to binary. So we have a question here that says convert 1F in base 16 to binary. So can we look at this together? Solution. So instead of we what? Using the long approach, right? Let us use what? The shorter what? Approach. The shorter approach is that each of these numbers in base 16 will be assumed to be what? In base 10, right? So we have 1 and we have what? F, right? So each of these numbers will now be what? Divide repeatedly by what? By 2. So 2 in 1, 0 remainder 1. So how many 2 can we see in F? You remember, what is our F? What does this F stand for? 15, right? So 2 in 15, 7 remainder 1, right? 2 in 7, it is what? 3 remainder 1. 2 in 3, 1 remainder 1. 2 in 1 is 0 remainder 1. So our answer will be what? Will be this. For this one, we have 1. For this, we have 1, 1, 1, 1, right? But, you know, the answer should be what? 4 bits for each of them, right? So what will be the equivalent of this one here? So we'll add 3 0 to the left of what? That one. This one is already 4, right? So the next thing is to what? To bring the 2 together, right? So we'll bring the 2 results together. It will be 0 0 0 1, then 1 1 1 1, right? So our answer will be 1 1 1 1 1 1 2 3 4 5 in base 2. Sorry, since I have this one in figure, this one too should be in figure base 2 like this. So I believe that one is clear, right?
Yes, sir.
Now this is an okay. Before the exercise question, we have a question here that says convert the hexadecimal fraction 0.68 to its decimal equivalent. Now solution is 0.68. We have it in base 16. C8. We have it in base 16. We are asked to what? To write down its what? Decimal equivalent. So is decimal equivalent, what will it be? So now you know now, let us what? Let us use the exponent approach in this case. So the power for the number before the point, the integral part, the normal way we always make the assignment, the first number to the right should be power 0, then we'll keep increasing it. So we only have one digit there, so the power will be 0 here. So the one after the point, the first power will be -1, then -2 like that. So it's going to be what? It's 0. Let us write down the expansion. This 0 times the base 16. What is the power that corresponds to this?
0.
It's 0 plus c times what? 16 to what power? -1. 8 times what? 16 to what power? -2. So what is 16 to power of 0? 1. Is 0 times that one is gone. What is c? C is what?
C is 12.
12. And 16 to the power of -1 is what? 1 upon 16. Plus, here we have 8. 16 to the power of -2 is what? 1 upon 16 to the power of 2.
Yes.
And 16 to the power of 2 is 256. That is 2 to the power of 8. So here now, we can use, okay, that is 12 over 16 plus, yeah, 8 in 256. That is 64, I know. That would be 64, meaning reduction of 2 from 2 to the power of -8. That is 1 over what? 64, right?
Yes, sir.
So, the LCM of 16 and 64 is what? 64. So here we have 16 is 64. That is 4. 4 times 12, 48. Plus 1, right? So what do we have? 49 upon 64. We can decide to what? To punch this on our calculator to have the answer. The answer will be 0 point something. So we can complete that from our end. So that will be the answer, or we can leave this one to be our answer. But you can punch your calculator. Can someone punch calculator and tell me the answer?
Punch. That punch. 4.76565. 4.76565. Okay, check out the
It is 0.765625. 0.765625 in base 10. So this is the answer in base 10. So the exercise question, that is the practice question for you, is this. The practice question is this. You have to convert the first one. You have to convert 3A5 in base 16 to binary. B, you have to evaluate, I'm coming, the expression, pardon me, I'm coming. You have to evaluate this expression 2B plus 17 minus C. So everything there, they are in base 16. So those are the two questions you'll be solving.
That's good.